modeling, and documenting software architectures. This chapter introduces different type of documentation where we try to introduce how we can document any software architecture. This the material introduced here are taken or presented in one of the books which is documenting software architecture views and beyond. بهذا الشابتر رايحين نتعرف على نوع مختلف من الدوكيومنتيشن وهو documenting السوفتوير اركتكتشر. رايحين نحاول نتطرق لانه او نتطلع على الاركتكتشر للسوفتوير from different views. والماتيريال اللي ماخوذه بالشابتر هذه هي اصلا من كتاب اللي هو documenting software architecture views and beyond اللي رايحين نحكي عنه later. Outline. In this chapter, we will introduce three things. First, we'll talk about introduction, where we try to present what we mean by software architecture, what we mean by views, and what are the type of software architecture and views that we can introduce in our document. The second thing, we will talk about documenting software architecture, views, and beyond. And this will be taken from, as we said, the documentation or documenting software architecture views and beyond book, which is a comparison from the Software Engineering Institute views and beyond approach for documenting software architecture. Introduction. First, a software architecture determines the blueprint for the project and team developing the software. When you develop a software, you need a specific design or a layout so you can design your software or develop your software based on this layout or this design. We call it the architecture, or sometimes we call it the blueprint of the project. Imagine that you are building a home. The first thing that you wanna do it, you will ask an engineer to print the layout for you or do the design for you. Teams are formed around architectural elements, which are units of implementation, unit testing, integration, configuration management, documentation, and host of other activities. Usually, when any development team consists of different members, each member will do or finish a specific unit or a specific element. These elements can be units of implementation, units of testing, integration, configuration, documentation, and other activities. Unlike code, architecture is a design artifact largely intended for use and analyzed by humans. Let's think about code and architecture. Code is like a set of statements where the computer only can understand or can translate, while the design is intended. When you design architecture, intended for use and analyzed by only a human. Representing the architecture in a readable, accessible fashion for its stakeholders becomes an issue of a great importance. Since it's readable by humans, so we have to present it in a readable and accessible way. Architecture gives the marching order to implementers. So it will be their guidance for the implementers or the people who implement the system. Tells them what pieces to build and how those pieces should behave and interact with each other. Let's go back and think about the architecture. When I think about the architecture, it's like where you put the components, the pieces of the software, the system, and how they interact with each other, how they are structured, organized, or ordered. And usually when we design the architecture, we give our implementers the guide so they can design and build our software. We mentioned in the previous slides that the implementers or developers use the architecture so they can know how to build the components and they put the relation between them and how they design them or order them. Also, the architecture determines the project structure for managers who use it to plan, schedule, and budget, or define the budgets. Also, it gives the first glimpse to the system maintainers who must change the architecture and the new team members who must become familiar with it. Also, people who can benefit from architectural documentation are the maintainer who want to change software or change the architecture, or like the new members who want to add the new components to the system. Therefore, architecture documentation has emerged as an important architecture-related practice. Research at the Carnegie Mellon Software Engineering Institute published documentations or documenting software architectures, views, and beyond, a book published by Addison Wesley in 2003. And this is the book that we are taking this material from. Documenting software architecture, views, and beyond. The views and beyond approach that we are discussing in this chapter holds that documenting a software architecture is a matter of first, choosing a set of relevant views of the architecture. Second, documenting each of these views. And third, documenting information applies to more than one view or to the set of views as a whole. In general, what we do in the 3 steps: first, we'll try to find all the views that can apply to our software, document each of these views, and in number 3, we'll try to merge these views and take the information that applies to all of them or to some of them. The last step, which is step 3, ties the views together and make them become holistic and integrated representation of the architecture, as opposed to the disjoint snapshots taken from different angles. What we mean here, with step number 3, we try to tie all the views or most of the views together so we can take a holistic view or holistic picture about our software, instead of just looking at the views in separate views or that are not complete or that doesn't complete the whole view for the software or the picture. The detailed approach includes a method to choose the most relevant views, standard templates for documenting a view, and documenting the view and documenting the information beyond the views, and definition of the template content. Documenting software architecture is a matter of documenting the relevant views and then adding documentation that applies to more than one view. This is what we described in the previous slide. Why multiple views? Why we cannot get just only one view and represent the system using it? Modern software architecture practice embraces the concept of architectural views in the IEEE 1471 standard. A view is a representation of a set of system elements and the relations associated between them or associated with them. So now if we look at the view, it's a representation between the system elements and the relation between them. Views are representation of the many system structures present simultaneously in the system. Modern systems are too complex to be grasped all at once. Instead, we restrict our attention to any one moment, to one of the software system structures, which we represent as views. Now, if we look at any software these days or any systems are complex. So we can't understand them if we think about them as a whole. So we have to take them in parts, different views, and try to understand them and integrate them all together. Different kinds of views. There's an almost unlimited supply of views to choose from. To lend some order to an otherwise chaotic collection of possible views, it's helpful to think of the views or to think about views in groups. We call them viewpoints. يوجد العديد من الفيوز that we can use to represent our software or our system. These number of views are chaotic, like it's not an order. So we can order them, or to give them order, we put them in groups, and we call these groups viewpoints. According to the kind of information they convey, we can describe them in different models, in different groups. First group, model views, describe how the system is to be structured as a set of code units. Second thing, component and connector group or views, describe how the system is to be structured as a set of interacting runtime elements. Number three, deployment or allocation views, describes how the system relates to non-software structures in the environment. هذول هم three groups we call them viewpoints. This is our way to order or all the possible views when we try to document our software. Now, a view is a representation of a structure that is present in a software system. So we have different architecture styles we can use. First, one might show the hierarchical decomposition of the system components or functionality into modules. For example, classes, libraries, and packages. Another one show how the system is arranged into layers. Another might show how the system accomplishes work through communication processes or the interaction of a client and server. So when we try to describe the components, or when we try to describe the system structure, we can describe it as modules, which is the classes, component, and libraries, and the relation between them. We can describe it as layers, where, like for example, like the lower layer can only contact with the one layer above it, or take services from the layer one above it, and so on. Or we can describe it as client and server or communication processes. All these are styles that we can use them. Still, another might show how software elements are deployed into hardware processing and communication tools. Another way to represent our components or our system is using a deployment, architecture or style. What we mean by a style is a specialization of element types. For example, client layer and relation types is part of request reply connection is allowed to use, along with restrictions. Client interact with server, but not each other. All the software comprises layers arranged in a stack such that each layer can only use software in the next layer. This is a description of a style. The style consists of three parts. First, element, relations, and restrictions. Okay, element can be, for example, client, server, layers, and so on. A relationship between them, for example, we can say this is part of, this is a request reply connection, this is allowed to use, for example, component A allowed to use B, and so on. And the client and the restriction, for example, we can put some restriction on, the communication between components or elements. Clients interact with server but not each other. All the software is comprises layers arranged in a stack. Okay, these kind of restrictions we can put in our in our design or our style. Styles. Each style describes a system category that encompasses four things: components, connectors, constraints, and semantic models. First, a set of components, for example, database, computational models, packages, libraries that perform a function required by the system. Second, a set of connectors that enable communication, coordination, and cooperation among components. Number three, constraints that define how components can be integrated to form the system. Number four, semantic models that enable a designer to understand the overall properties of a system by analyzing the known properties of its constituent parts. We have here we can mention five different styles: data center architectures, call and return architecture, layered architecture, data flow architecture, and object-oriented architectures. Importance of documenting an architecture. To communicating to stakeholders the blueprint of the system you are building is to document the software architecture. لما بنزود stakeholders, managers, developers, designers بالبلوبرنت والسيستم اللي احنا بنبنيه, that's our way to communicate with them or our way to document our software. By documenting the different views and capturing the development of each part, you can communicate information about the evolving system to the development team and to the business IT stakeholders. A software architecture that has well-documented architecture provides, first, a perfect platform for educating new team members about what the solution, an explanation of how solutions meet business and engineering goals, various views of the solution architecture specific to the problem domain, and focus on the view that an individual will work on. Steps of the methodology. Here we mean the steps for choosing the views to document. The steps are based on, first, the software architecture, who are our stakeholders, and the concerns that they have that would motivate them to document the chosen view. فهنا choosing the structure or choosing the step بيعتمد على three things: software structure, the stakeholders, what motivates them, what kind of concerns motivated them to design or to document the view. The first step, produce a candidate view list. So build a stakeholder view table of your project, enumerate the stakeholders for your project, software, architecture, documentation down the rows, enumerate the views that apply to your system. Some views, for example, the composition, uses, work assignment apply to every system, while others like the pipeline or pipeline filter layer and the layered only apply to systems designed according to the corresponding styles. الستيب الاولى اللي هو we have to produce candidate view list. نعمل تيبل، هذا التيبل بيحتوي على الستيك هولدرز والفيوز. ف بدنا نحط الروز على شكل ستيك هولدرز والكولوم على شكل views. We put them in groups. في عندنا different type of views. Some views apply to every system مثل decomposition, uses, will, work assignment. We can apply them to any system. في عندنا بعضهم we can apply them to just some systems like type and filter, will, layer views. What kind of views that we might have? We said earlier that we have different three viewpoints or view groups: model view type, component and coordinator view type or viewpoint, and allocation or deployment view type. Within the model view type, we have four views: decomposition, uses, generalization, and layout. Within the CNC or component and connector view type, we have data stream, call and return, shared data, publish, subscribe. Within the allocation view type, we have deployment, implementation, and work assignment views. We said the first step to create reviews is to create a candidate view stakeholder list. So here we have a list of the stakeholders or the people they might use our document or our system. For example, current architecture or future architecture, project manager, testers, maintainer, analysts, and funding agencies, and so on. This list can be different from system to system. Okay, and here we put a list of the views. We put them in groups according to the view. For example, model view, decomposition, uses, layered, CNC view or component and connectors view, allocation view. This describes the kind of information that might be included for each one of the stakeholder. For example, when we talk about the decomposition view, for the current and the future architects, they need, for example, detailed view or detailed information. If we talk about project managers, we need some details, and sometimes we don't need, or we need just overview information when we deal, for example, with the agency or funding agency people. Step number 2, which is combine views. The candidate view list from step 1 is likely to yield an impractical number of views. We looked in the previous table, we have 9 views we can apply them. In step 2, we try to winnow the list to manageable size. بنحاول انه نختصر هاي الليست، بنحاول نضيقها بحيث انه ايش؟ ناخذ manageable size او اقل عدد من الviews. First, look for views in the table that require only overview depth or that serve very few stakeholders. See if the stakeholders could be equally well served by another view that has stronger consistency. أول شيء بنحاول حتى نقدر نعمل eliminate أو نختصر من هاي الفيوز، بنحاول نطلع على الفيوز اللي إيش just require only overview that have the all thingy depth or that serve few stakeholders أو اللي بتخدم أقل عدد من الستيكهولدرز إيش بنحاول إيش نشيلها. Next, look for views that are good candidates to become combined views. ممكن نلاقي إنه بعض the views can be combined together بحيث إنه إيش to be stronger and serve more like candidates. A combined view show information native to two or more separate view. A rule of thumb that if there is a strong correspondence between the elements in two views, they are good candidate to be combined. إذا لقينا إنه the two views serve the same set of elements, okay, or they serve the same set of stakeholders, then we can combine them or we can merge. Step number 3, prioritize. After step 2, you should have the minimum set of views needed to serve your stakeholder. At this point, you need to decide what to do first. For example, some stakeholders interests supersede others. The project manager, for example, of a company you are partnering with often demand attention and information early and often, and you may want to cater to her needs. For example, the project manager, they like to see or they like to be convinced first. عشان هيك عشان نقدر نعملهم we might need to choose the views that are related to the stakeholders and try to design them or present them first. Templates for views and information beyond the views. This slide presents template for the view packet. The documentation for it is placed into a standard organization or template comprising 7 parts, 7 sections. Section 1, Section 2, Section 3, Section 4, section 5, section 6 and there's section 7 in the next slide. هذا السلايد بيمثل عبارة عن template للفيو باكيتس وبتكون من 7 sections. الفيرست section هو البرايمري presentation. The primary presentation shows the elements and the relation among them. هنا بنطلع على انه shows the elements and or ممكن يكون عبارة عن textual representation لمين للبرايمري elements. السكند thing اللي هو ايش؟ elements catalog. Elements catalog details the elements depicted in the primary view. كل الاليمنتس اللي انعرضت section number 1 نحاول انه نعمل لهم ايش؟ details or more details including the properties with interfaces. If any elements or relation relevant to the views bucket were omitted from the primary presentation, the catalog is where they are introduced. إذا any of the elements ما ذكرت بالprimary, there will be listed or we will talk about it in the element catalog. Section number 3 اللي هو context diagram. The context diagram shows how the system or portion of the system depicted in the primary presentation relates to its environment. بيحاول يعمل link بين الانفايرمنت وبين الاليمنتس او السيستم اللي ذكر بالبرايمري presentation. An architecture background or rationale explains why the design reflects in the view packet came to. هذا اللي هو ايش؟ الفايابيليتي or بعدين رايحين نحكي عن الفاريابيليتي جايد اللي هو section number 4. Section number 4 guide shows how to exercise any variation points that are part of the architecture shown in the view part. Section 5 اللي هو architectural background والarchitectural background or relational or rational explains why the design reflected in the view bucket came to be. بحاول يعطيني background أو relation أو rational أو reasoning why each part of the architecture are used. هون بيعطيني design rational analysis of result with assumptions. Section number 6 اللي هو other information. بالother information section contains items that vary according to standard practices of each organization or the needs of the particular project. In section number 7 or part number 7, the other information, we can answer how the documentation is organized, documentation roadmap, review templates, also what the architecture is, system overview, mapping between views, directory, glossary and acronym list will be listed. Why the architecture is the way it is. Section number 7 presents background, design, constraints, and rationale for each part of the views. Template for documentation, view, or beyond the views. The final piece of the architecture document is the information that applies to more than one view and to the entire package. It ties together the views and provides a holistic picture of the total design. الفاينل اوتبوت او البرودكت لعمليه الفيوز اند بيونز اللي هي عباره عن برودكت بيعطينا الهول بيكتشر او الهوليستيك بيكتشر الكومبليت بيكتشر عن هاي الفيوز and how they are related to each other. هذا التمبلت او هذا الدوكيومنت بتكون من 7 sections او 7 parts. Section 1 اللي هو documentation roadmap. The documentation roadmap is the reader's introduction to the information that the architect has chosen to include in the suite of documentation. هو عبارة عن introduction بيوفرها الاركتكتشر للريدر بحيث يعرف ايش هي البارتس من اللي اختار او ايش هي الفيوز اللي اختار الاركتكتشر to put in their document. بيعطينا brief description about each part of the documentation package. كمان بتعطينا ايش brief description عن ال view element types, relation types, the property types, the purpose from them and the stakeholder for each part of the package. السكند part أو second section اللي هو الفيو template. الفيو template is the standard organization for the view. هو إيش؟ Its purpose is to help reader navigate quickly to a section of interest. عبارة عن الجنرال أو الأورجنايزيشن للفيو كونتنت أو للتمبلت، وهذا بيساعد على إنه اليوزر يتنقل بين التوبكس أو بين السكشنز easily. Number 3, system overview. A system overview is a short prose description of what a system function is, who users are, and any important background constraint. هو عبارة عن description للسيستم، who is using the system، ايش الباكجراوندز، ايش الكونسترينز عليه. Or this or the purpose from this section is to provide the readers with a mental model of the system and its purpose, so it will be easy to understand it or comprehend it. Number 4, mapping between views. This shows the correspondence between individual elements in different views, helping a reader or other consumer of the documentation to understand the relationship between views. This will help the reader gain powerful insight into how the architecture works as a unified conceptual whole. هون بيحاول يصور لي ايش الكومبوننت، ايش الباكجز والكيوز، وايش طبيعه الريليشن بيناتهم، حتى ايش، حتى يقدر يوصل لليوزر or to give a reader a complete picture about how the architecture is working as a whole. Number 5, directory. The directory is simply an index of all the elements, relations, and properties that appear in any of the views, along with a pointer to where each one is defined. فهو عبارة عن list أو index بكل element والrelation والproperties الموجودة بالviews، بالإضافة who are using it and how they are defined. Number 6, project glossary and acronym list. The glossary and acronym list define terms unique to the system that have a special meaning. These lists, if they exist as part of the overall system or project documentation, might be given as pointers in the architecture package. هم عبارة عن list من acronyms or keywords that are related to the system or have a special meaning for the system. Number 7, cross-view rationale. This section documents the reasoning behind decisions that apply to more than one view. Prime candidates of the cross-view rationale include documentation of background or organization constraints that led to decision of system-wide import. هنا بنركز على ايش الreason behind or decision behind choosing any of the views and present them in our document. At the end, there will be example or set of examples to represent how documenting software architecture for real software will be done and what's the standard template for this.